Good morning and once again welcome to my YouTube channel, Pearson and Excel International Maths by Mr. Kamoto. And in this video we are going to learn something to do with direct proportion but nonlinear. Yes, direct proportion but nonlinear. And I just want us to just concentrate on the textbook. I hope it's clear on my video. Sometimes we may have direct proportions that are not linear. And the example that is illustrated in the textbook is quite perfect. And we are told that water is poured into an empty inverted cone. Each liter poured in will result in a different depth increase. Of course, you will agree with the diagram or with the explanation. The very first liter of water poured in the cone will occupy a great height. It will occupy a great height. And as volume now increases, the depth also increases, but of course not in the same proportion. Just because there is a bigger surface area on top than the bottom, it is important a graph of volume y against depth x will illustrate a direct nonlinear relationship. For example, this is a graph of a cubic relationship, and this relationship can be expressed in either of these ways. Directly, y is directly proportional to x cubed, or y varies as x cubed. It is important to talk about nonlinear. Nonlinear, you will be given all the details as far as the question is concerned, and you will just be told y is directly proportional to x cubed, and y varies as x cubed. You will be given cubed here is quite important, and it's the same thing that is seen over there. It's very, very important. And both statements can mean the same thing. And in symbols, this relationship can be written as y varies directly as x cubed. Of course, what we do, we replace the symbol of proportionality with equals k. Y is equals to kx cubed. Again, remember k is still a constant. This one is still a constant, and x and y are variables. It can also be square root here. It can also be a square root here. It can be a square root. It can be a square. It can be a fourth root. It can be anything, but all those details will be given in the statement. And I want us to directly go to example 2 so that we can explain it with an example. Express this relationship as equations with constant of proportionality. Now, y is directly proportional to x squared. Y is directly proportional to x squared, which gives us y is equals to kx squared. That is part A. Part B, m varies directly as cube of n. M varies directly as cube of n, which is m is equals to kn cubed. It's the same thing. Let's look at C. Part C, s is directly proportional to the square root of t. S is directly proportional to the square root of t, which translates to s is equals to k root t. It's just like that. And part D, which is I think the last one, v squared varies as the cube of w. V squared varies as the cube of w, which translates to v squared is equals to kw cubed. All these are a relationship of some variables, and that is exactly how we need to understand that part. And I think in the same video, we can explain example 3. We can explain example 3. Because in example 3, we are told that the cost of Luciano's takeaway pizza in cents is directly proportional to the square of the diameter. The cost of pizza C is directly proportional to the square of the diameter. To the square of the diameter. That is it. And this translates to the cost is equals to kd squared. There are details when C and D. There are details. We have details. A 30 centimeter pizza cost $6.75. So we need now to substitute this in this particular equation so that we can get the value of k. And C is 675 is equals to 30 squared k. And that is squared because D should be squared. And of course, K is 675 all over. That is squared is of course 900. And 675 divided by 900 is well 0.75. So the formula that is connecting the two is C is equals to 0.75 d squared. That is the formula. And we have answered part A. Find the formula for C in terms of D and use it to find the price of a 20 centimeter pizza. With this formula, we are supposed to find the price of a 20 centimeter pizza. Now, we have 20, we don't have the cost. We have 20, we don't have the cost. So the cost is 0.75 and the diameter is 20 squared. So this one translates to the cost is 0.75 times 20 squared, which is times 400. And it goes without saying, times 400. It goes without saying times 400. The cost is simply 300. The cost of the 20 centimeter pizza is simply 300 cents. Now, part B of the question. Let us now talk about part B of the same question. What size of pizza can you expect for $4.5? Of course, we have to have 4.50. This one has to be converted to cents because our question is already in cents. We are told that. So this one is 450. So the 450 is we are looking for, we have the cost, yes, which is 450. We're looking for the size of the pizza. 450 is equals to 0.75, which is the constant d squared. Now, if you divide both sides by 0.75, you realize that d squared is 450 divided by 0.75, which is well 600. And of course, this is d squared. To get d, we must get the square root of both sides, the square root of 600, and our d is simply 24.5. We have to have the root of answer, which is 10 root 6 or 24.5 to 1 decimal place. These are centimeters. So you have seen that we have been able to establish, we have been able to answer all the questions. This one is quite important, and I would wish that we all follow so that we don't get confused along the way. So kindly make sure that you understand the proportionality, whether it is linear or non-linear. Either way, the details will be given in the question. But in all of them, the constant of proportionality will have to be substituted by equals k, and that will take you home. You will never go wrong if you just take these steps one at a time. All right?